Hi, this is Professor Anil Kumar Sathe from Department of Mechanical Engineering, MIT School of Engineering, Pune. Today in this lecture we are going to see some part of testing of IC engine, that is Morse test. Now why this Morse test is going to be performed on the IC engine? This is one of the trial on the IC engine to be conducted in the laboratory to determine indicated power, friction power and mechanical efficiency. Before going to the Morse test, we will revise the definitions of indicated power, friction power and mechanical efficiency. What is indicated power? Indicated power is power produced inside the cylinder on top of the piston after combustion of fuel. What is friction power? Friction power is nothing but power lost in friction and power required to run the various auxiliaries like water pump, lubricating oil pump, dynamo, valve operating mechanism, in case of SI engine, ignition system, in case of fuel pump, that is a diesel engine, to get a drive for a fuel pump, we are requiring a friction power. Finally, the brake power. What is brake power? Brake power is the net power obtained by subtracting friction power from indicated power that is available at the end of the crankshaft to do the useful work. Now what is mechanical efficiency? That is the last definition what we have seen in earlier lecture. Mechanical efficiency is the ratio of brake power to the indicated power. The significance of mechanical efficiency is higher is the mechanical efficiency, lesser are the frictional losses and vice versa. This is what we have learned in the last lecture. Now let us continue with this test. How to perform this test, what is the principle of working we are using in this test, and what is the assumption of this test. Now starting with the very first important point about this Morse test. This Morse test is used only on multi-cylinder engine. Just remember this multi-cylinder engine word. Now what is multi-cylinder engine? If engine is having more than one cylinder, then it is called as a multi-cylinder engine. You can't perform this Morse test on a single cylinder engine. This you can say a drawback of Morse test. Now what is the reason behind it? That you automatically understand at the end of this lecture. Now the second point is, it is used for petrol or diesel engine. There is no any restriction as such on which engine it is going to be used. Only the thing is, it should be a multi-cylinder engine. Now the next one is a requirement of Morse test. What is the necessary condition while performing this Morse test? Remember, as the objective of Morse test is to determine the friction power, and friction power is a function of the speed of the engine. So while doing the Morse test, we have to keep the speed constant, because speed and friction power are directly proportional to each other. As speed go on increasing, friction power also increases. So we have to take care while performing this Morse test, the speed must remain constant. Now the next important point is assumption of Morse test. Most of the time students get confused with assumption and requirement of the Morse test. Remember students, assumption is different from requirement. Assumption of Morse test is friction power of working and not working cylinder remains same. Now we must understand, to understand this assumption, what is the meaning of working and non-working cylinders. Now this slide explains you what is the difference between working cylinder and non-working cylinder. Working cylinder means the cylinder in which combustion is allowed to happen, and non-working cylinder means the cylinder in which combustion is not allowed to happen. Now how to make the cylinder non-working from the working? Particular cylinder can be made non-working by cutting of the electric supply to spark plug in case of petrol engine, or cutting of the fuel supply in case of diesel engine or CI engine. Now we have to take certain example of an engine to explain this Morse test further. Consider 3-cylinder petrol engine to understand the procedure of a Morse test. Engine is started and throttle is adjusted to get some fixed value of a speed with some value of load W on the engine. Now the speed we have got on the engine is N, which is measured by RPM sensor, and the W what we have obtained by the dynamometer. So with this W and N we are running the engine. With this load and speed, brake power is measured by the formula. Now we have to do some calculations here. Now see here, this brake power is brake power of the engine when all cylinders are working. How to calculate this brake power? This is the usual formula. Brake power is torque into angular velocity, that is 2 pi n divided by 60. Now here there is a 60,000. This 60 is because of n is in RPM, we have to convert it in RPS, that is revolution per second. And why this 1000 is there? That is because we require brake power in the unit kilowatt rather than watt. Now how to get this torque? This torque is obtained by force into distance. So load obtained by the dynamometer into 9.81. This 9.81 come into the picture because I want to convert load, the unit of load, from kg to Newton, and this R is a dynamometer arm length. So we'll get the torque, and from the torque, after putting in that formula, we'll get the brake power in kilowatt. Now the next step is you have to cut off the first cylinder by the method described earlier. Now what we have assumed, this the engine in the Morse test is a petrol engine, so we are cutting the electric supply to the first cylinder, so it is made non-working. Now as soon as the first cylinder is made non-working, load remains same, that is W, and now that load is taken by only two cylinder, that is cylinder number 2 and 3, and the first is non-working. So what is going to happen? The speed go on decreasing. But as I have already explained to you, in the Morse test we have to maintain the speed constant. Now what we have to do? Decrease the load on the dynamometer, keep the throttle position constant, decrease the load on the dynamometer so that we can get the original speed n, and note down the new value of load. Of course it is a decreased load, and that is W1. So remember that W1 is less than W. What is W1? When the first cylinder is cut off. And what is W? When all cylinders are working. Remember here, W1 is less than W. Now calculate brake power 1, that is BP1. Remember one thing again here. BP1 is not brake power of first cylinder. It is brake power of the engine when first cylinder is cut off. How to calculate it? It is again the same formula of BP, 2 pi n multiplied by torque divided by 60,000. Only the thing is, here torque is calculated by putting W1 instead of W. Other procedure remains same. Now BP1 means brake power of the engine when first cylinder is cut off. Now switch on the first cylinder again back by supplying the electric current to the first spark plug, and cut off the second cylinder. Calculate BP2 by the same method as we have explained earlier. Finally, switch on the second cylinder and cut off the third cylinder and calculate brake power of third cylinder by the procedure explained earlier. Now let IP1, IP2, IP3 be the IPs developed by the cylinder number 1, 2 and 3 respectively, and their corresponding friction powers are FP1, FP2 and FP3. These are the symbols we require for the further derivation. Now brake power of the engine when all cylinders are working. For that we are writing the equation. What is the fundamental relationship between brake power, indicated power and friction power? Brake power is the difference between indicated power and friction power. That's what explained by the equation A. Now this BP is a brake power of the engine when all cylinders are working. That is written as BP is equal to sum of IPs of all cylinder, IP1 plus IP2 plus IP3 minus sum of the friction powers of all cylinder, FP1 plus FP2 plus FP3. When first cylinder is cut off, we can write above equation as total BP1. Now what is BP1? Brake power of the engine when first cylinder is cut off is equal to, this IP1 becomes 0 now here, because first cylinder is cut off means there is no combustion, and no combustion means indicated power of that particular cylinder becomes 0, but second and third combustion is going on, so that indicated power remains as it is. You can see here there is no IP1, but IP2 and IP3 is as it is, minus FP1, FP2, FP3 is the bracket remains same, because though the combustion is up in first cylinder, the piston is working in the first cylinder, valve operating mechanism is also working, then water pump is also working, lubricating oil pump is also working, and therefore friction power of that cylinder is not lost, that is as it is. So this bracket remains as it is. Now in the next slide, now subtract equation B from equation A. Just look at this. Equation B and equation A. If you are subtracting equation B from equation A, what you will get? Brake power minus brake power 1 is equal to IP1. What is BP? When all cylinders are working. What is BP1? When cylinder number 1 is cut off, second, third is working. And IP1 is indicated power of first cylinder. Now by subtracting equation B from equation A, we are getting this equation. In the similar fashion, we can calculate for IP2 and IP3. That is indicated power of second cylinder and indicated power of third cylinder. Now we are having individual cylinder indicated powers as IP1, IP2 and IP3. Just add these powers to get the indicated power of the engine. Now after getting the indicated power, we are having a brake power when all cylinders are working. We are having indicated power of the engine. Now just subtract IP minus BP, you will get the answer of friction power. And as I have already discussed, what is mechanical efficiency? It is the ratio of BP and IP. We are having both the values with us, BP and IP. Just take the ratio and multiply by 100. We will get mechanical efficiency in percentage. Now remember, there is one limitation of Morse test. Friction power calculated by Morse test is having some error because of the assumption made. What is the assumption made here? Just recall it. What is the assumption? Assumption is friction power of working cylinder and non-working cylinder remains same, but it is not so. Friction power of working cylinder is always little greater than friction power of non-working cylinder, and because of that slight error is introduced in the calculation of friction power while performing the Morse test. That's it for today. Thank you.